Good day everyone. Welcome to our second video for physical science. This is our activity sheet for quarter 2, MELC 9, week 4, wave-like properties of electrons. So in this video episode, we will be discussing again the solving problem of this activity. So it is about the Broglie's wavelength. So the Broglie's wavelength is represented by lambda. Lambda is the 11th letter in the Greek alphabet, which is equal to the h, which is the Planck's constant, divided by m, which is the mass, times v, the speed or velocity of the object. For clearer understanding of this, we will discuss problem number 1. So what is the Broglie's wavelength for a ball bearing a mass of 0.02 kilogram and travels at 330 meters per second? So we will write first the given. The given is from the problem. Mass is equal to 0.02 kilogram. Kilogram because, or it is a mass because kilogram is the unit of mass, and it is mentioned also as a mass. And 330 meters per second. How will you know what is the quantity it belongs? So the unit is meter per second, which is the unit given for velocity. And the remaining factor there is h. H is equal to the Planck's constant, which we had discussed before, which is 6.63 times 10 to the minus 34 joules time second. So what is required? What is being asked in the problem? It is the de Broglie's wavelength. And the equation for de Broglie's wavelength was given above as h is equal to the mass times the velocity or the speed. Okay, our next step would be the solution. In the solution, you only have to substitute the given data to the formula. So lambda would be equal to the h, which is the Planck's constant, 6.63 times 10 to the 34 minus 34 joules times second, divided by the mass, which is 0.02 kilograms, times the velocity, which is 330 meters per second. And then we will, if you notice, there is no, the exponent is, or the scientific notation is only on the numerator, and the denominator, these are ordinary numbers. So there is no need for us to use the exponent when we divide. Okay? So when in dividing, it would be 6.63 divided by 0.02 times 330, which is equal to 6.6. 6.63 divided by 6.6 is equal to 1.00454. So using the significant figures, if we will have to really look at the least significant figure here, would be 2. So the best answer would be 1.0 times 10 to the minus 34 meters. Why minus 30 times 10 to the minus 34? We will just bring or carry over the exponent of the numerator to the answer. That is why. So, but the answer here is 1.00 times 10 to the minus 34 meters. 1.0 will be accepted. 1.00 times 10 to the minus 34 will be also accepted. Now, the meters. Why is it the unit? The final unit is meters. So, let me show you. Here we have joules. 1 joule is equal to 1 Newton meter. And 1 Newton meter is equal to 1 kilogram meter per second squared. So, joules, the joules can be represented with this Newton and then the meter. But 1 Newton is equal to kilogram meter per second squared. And we carry the meters. And then this S comes from here, the joules times the S. That is why the numerator's unit would be kilogram meter per second squared times meter times second. And the denominator, the unit is kilogram meter per second squared. Simple. Now, to simplify more these units, to show you a easier way of canceling the units to arrive to meters, so the final would be kilogram meter times meter times S times S divided by kilogram meter second squared. Now, if you write this class, now kilogram meter per second squared, that is in the numerator, and here kilogram meter divided by the second. So when you have to multiply it, the final answer would be this. So we can cancel, because this is in the numerator, this is in the denominator. We can cancel the kilogram, meter, the 2 seconds, second squared, and the 2 seconds here. What is left is this meter. Okay? That is why the unit is meter. So if you find this hard here, as long as you know why or how that the final unit is meter, it's okay that there you need not show this. After this, joules times S divided by kilogram meter per second, just write the final answer as M. It is acceptable. I will accept that without showing this different cancellation of units. Okay? Now, number 2 will have the same procedure, steps the same, but number 3 is different. We will discuss number 3 in our next video. Thank you, and I hope that you were enlightened a little bit, if not really enlightened, and I hope that I help you to learn some more. Thank you so much for watching.